Okay, so in this first talk, it's kind of a general talk on the status of the mission, and it's in, sorry. Okay, so I'm going to cover several topics, and first an introduction, and I will spend some time because we are in Europe, and just to tell you about JWST, and especially from a point of view of the contribution of Europe to the mission. Then I will move to the mission status, one big item, which is the launch date, and its recent move to spring 2019. And then I will show you it's more pretty pictures and some explanation of what is happening. So talk to you about the hardware status and with pictures. And then I will finish with one slide on what's next on the ground. I will stop at the launch, basically. After that, there are some other steps, commissioning and then science. But I will just give you an idea of what remains in front of us between now and launch. So let's see if I can manage. Okay. And I think I missed the acknowledgement. Just to say, it's a presentation on behalf of a very big team. So, of course, the slides I'm presenting, some of them are stolen from other presentations, and it covers basically the work of a lot of people. So, the European participation. So, first, JWST is a partnership between NASA, ESA, and the Canadian Space Agency. This has been the case since the very early phases of the mission, and that's where you realize how long the thinking about JWST is starting to really thinking seriously about it, then starting building things. You come back a long way, because basically ESA and CSA were invited to join the project in '97. So we are talking about 20 years ago. And in terms of Europe, basically the contribution of Europe to the project was consolidated around 2000, and the formal acceptation of this participation, I think, has been in 2003. So we are talking about a big mission, but also it's big in terms of time scales. And in return for this contribution, in fact, at least 15% of the total JWST observing time will go to ESA member state applicants. So that's the deal. We contribute, and in return, the scientists of the member states get access to the facility. And that's basically following the same scheme than the one which was very successfully applied to HST. In fact, in JWST, Europe has an important and visible participation. And what you see is the three blocks that you find usually in a mission. So the launch segment, what is needed to launch your facility in space. You have the observatory segment, which is basically the satellite of the observatory, and the ground segment, so everything you need to communicate with it, but also to operate it, okay? And in fact, in pink, kind of red pink, it's provided by ESA in Europe. And what you see that basically the launch segment is provided by Europe, because JWST will be launched by an Ariane 5 rocket. You can see also in the observatory segment is that one instrument, NearSpec, and I will come back on that, and also MirI, partly MirI, are provided by Europe. In gray, what you see is that the Canadian Space Agency is providing the nearest instrument and the guider for JWST, and all the other elements are basically provided by the US. On the ground segment, you will find, as I said, on the right, you have the deep space network, so that's communicating with the satellite. And on the left, you have more operating. And the Scientific Operations Center for JWST is STSCI in Baltimore. And you will find actually many people from STSCI also supporting this workshop. And ESA is actually providing a team of 15 ESA staff members, and they will work together with their colleagues at STSCI and supporting, in particular, the MirI and NearSpec instrument, but not only that. So to give more details, the launcher, it's one of the Ariane 5 ECA. As you can see here, I will not come back really on that later, but we have to launch folded. So JWST is a satellite that we will need to unfold once we launch, and all the very careful, progressive deployment is basically taking roughly 3 weeks between. It will be complete 3 weeks after launch, basically. We are deploying the satellite as the satellite moves toward the Lagrange 2 point in space. So In terms of launcher, one nice thing is that the Ariane 5 rocket is, I think from the latest launch, it has made 81 successful launch in a row without any failure. So that's very reliable. And we like to put this satellite in a reliable rocket. You can imagine. Okay. In terms of the other contribution, I've said about 2 instruments. So one is NearSpec, so it's the near-infrared spectrograph. And it was actually built by a consortium of European industry for the European Space Agency. And you will see this map also for MirI, but you have the blue and the red points, or points where institutes, industry contributed to NearSpec and MirI, the different colors. And what you see, it's really a European endeavor, basically. And I will not detail NearSpec, just to highlight this is one of the contributions. And MirI is actually, when we talk about MirI, it's encompassing several systems. It encompasses the instrument itself, the optical system, which has been built in Europe, so by a consortium of nationally funded European institutes. The PI in Europe is Gillian Wright. But it also, the optical system includes detectors, and also MirI is operating significantly colder than the rest of the observatory. The observatory typically is around 40 K, and MirI has to be cooled down to 6 Kelvin. So the observatory is cooled down passively, meaning you put the observatory in the shadow. You will see there is a big Sunshield in the next slide, and it will cool down passively to 40 K. But to go down to 6 K, you need an additional cryogenic cooler, and it's a mechanical one, and it has been developed by NASA. It's provided by NASA JPL. So that's why MirI was dashed in terms of European-US contribution, because that's a joint endeavor. And the last part, so the team, the 15 ESA. In fact, the team is led by Marco Sireni, who you saw just before. And it's currently a team of 12. And by the time we launch, it will be a team of 15 people. And it includes mostly scientists, but also engineers who carry the knowledge about the instruments on the operation. Okay, so that was the JWST in a nutshell, and especially with respect to the European contribution. Now we move to the status, and very recently, last week, it was announced that JWST will now launch in spring 2019. The launch date for years now, since 2011, had remained October 2018. And, but recently, basically, NASA took a look at where we were. And we are advanced, but we also took a look at what do we still have in front of us. And the conclusion of this very detailed schedule assessment was that basically this schedule, which was set up in 2011, included margin, but still, when you look at how much time it took to do some things, how much time we know, now that we have much better experience, we think some steps we'll be taking, we would not be, it would be unlikely that we are already in October 2018. So the launch date has been moved to 2019. And spring 2019. And why spring? It's because when you launch, in fact, formally, around this date, you have to tell Arianespace, because they have to schedule their rockets and everything, you have to give them a 90-day period, which is when you think you will launch. Okay, so here what NASA and in coordination with ESA gave them is March to June 2019. JWST doesn't have a fixed launch window. Okay, it's not a planetary mission where you may have 2 windows in a year. So you can every day you will have, except some restricted period, you have some windows where you can launch. So we are not. It's not like we can launch only the 2nd of March and the 2nd of June. It's actually well spread over the 3 months. And so that's the status right now, is that the launch date has been moved to spring 2019. So one important thing from my point of view is that it's not that we delay launch because we are having problem with the hardware. Okay, it's not that we have a problem, we have to, something is really big problem we have to fix and we are getting in trouble. It's not driven by conservatory. In fact, all the tests and measurements we have done so far indicate that we should deliver what we promised. Okay, so it means a powerful observatory. And but what happens is that when you look at the, as I said, you look at the steps, you realize some things you thought you could do in parallel could have to be done in serial. Some things are taking longer. And for me, one important thing is that this is also, you have to realize, this means that NASA is not cutting corner, because you could take the approach of saying, yeah, I just remove some tests, I just try to do things faster. But there's a point where you have invested 20 years in preparing this mission. You really have to do things right. So for me, that's the, you're never happy to announce that you move the launch date, but I think this is doing the right thing, okay? And this is not because we will have a mission that does not meet its performances. So that's the take about the status. Moving to spring 2019, JWST has a commissioning period of 6 months. So it means that basically we are not talking about the start of cycle 1 in winter 2019. Okay, and I think Jeff will talk about scientific timeline after. So I did not cover. Just the hardware status. In fact, this is JWST, so this is a rendering, a CAD rendering. So you see the big blocks which are on top the telescope, and on the back of the telescope you have the instruments. This is what is called OTIS, so the optical and the integrated science. So it's basically telescope and instruments. Then the second part is basically made of a Sunshield. As I said, we are passively cooled, so this big Sunshield is just there to keep permanently the telescope and the instruments in shade, so that they cool down passively to 40K. And on the sun side of the Sunshield, you're going to find the spacecraft. Okay, so where you have propulsor, you have carburant, you have communication, you have also some control electronics. And one thing, this thing here, it's not solar panels, they're actually on the side. It's actually because we are flying a big sail. You can imagine it's a tennis court size Sunshield. So it's actually a big sail with respect to a solar wind. And this momentum flap is actually used to balance a little bit, to help momentum management. But the solar panels, they are actually under the Sunshield. So right now, at this stage, JWST is made of 2 blocks. Okay, many elements have been integrated together, and we have OTIS, so telescope and instrument on one side, and Sunshield and the spacecraft on the other side. So that's what remains to be put together. And if I focus first on OTIS, and this is and compared to the spacecraft, it's a very shiny and nice piece of hardware. So this is the primary mirror, and you can see actually here, this is the structure supporting the secondary mirror, which is folded in this picture. And the instruments are in a backpack at the back of the primary mirror. And OTIS is actually in the last stages of its what we call, in the lingo of space missions, the environmental test campaign. Okay, it's really at the last steps, and I will come back on that. You see it actually entering a big cryogenic chamber on this picture here. But before we use a cryogenic chamber, when you do environmental testing, usually what the first thing you check is, will my hardware be able to be launched? Okay, and it means rocket, the launch of a rocket, it means vibration and acoustic. A lot of sounds, a lot of vibrations. So usually what you do is vibration and acoustics, and then you do your cryogenic, where you check that everything is fine, because you need first to submit to the launch conditions, and then you check. And it's launched folded, so you have to test it folded. So what you see on the left is actually the folded OTIS. It's not the full JWST yet. And you can see we have folded part of the primary mirror is folded on the side. So the wings with 3 mirrors are actually on the side. And when you go for vibration and acoustic, you still want to keep your satellite very clean. So it gets, actually, it's a portable clean tent. And you can see the scale with respect to the people around. And acoustic is done by putting, actually you have huge loudspeakers, we call them horns. And what you see here is actually OTIS in its tent being moved in the acoustic chamber. So it went through acoustic testing, and it went through it successfully. The next step was to actually go through vibration. Actually, it must have been I may have swapped the two. And you do the same thing. Same thing, you bring, on the crane here, actually, you can barely see it inside, but OTIS is inside the tent, and this is the big vibration table. It's at the Goddard Space Flight Center. So OTIS was also submitted to vibration, and actually, this was one of the harshest steps, because when you test for launch, you actually test to levels higher than what you expect from launch, because this is what we call qualification level. And so these were some of the highest vibration tests it would see, actually higher than launch. And then it went through all that successfully. You want to test it at operating temperature. So it's a challenge, because 6.5 meter diameter telescope in a cryogenic chamber. And here you want it fully deployed, because there were some optical tests. So the telescope was also tested with instruments. So it's, in fact, there is a very big chamber, and I still did not manage to figure out if it's really the largest in the world or not, because, but probably. And at the Johnson Space Center, it was actually used for the Apollo program. And I think there is a clearance, a fairly small clearance you can see at the top when you move everything in. And they were brought down to 40K, MirI to 6K. And they were tested, the instruments, but also the telescope, because you want, you're launching a segmented telescope that you will align in orbit, that you will phase in orbit. So you want to make sure that you're mastering this part. So this has been tested. And in fact, I was almost tempted to say cryogenic testing is done. Formally, not completely. We went through acoustic, we went through vibration, and cryogenic testing, we are actually right now, the hardware is warming up. So we are going back to operating temperature, but while we warm up, we still do some tests. So formally, it's not completely finished. But from this part, OTIS, so far, the telescope and the instruments are, meaning everything indicates that they will be fit for launch, they are in good shape, and they are performing well. It's a nice picture. It doesn't mean everything, we don't get a bumpy road from time to time, because you cannot, I would be lying, meaning no project like that can go completely smoothly, but it means when we encounter problems, there are things fixed along the way, and so far no showstopper has been, as we have not faced any showstopper. The second block, spacecraft and Sunshield. So here, what you see is, so that's still the CAD rendering. You see the Sunshield. So these are, and I believe this is really a picture of layers of the Sunshield, the flight one, so the one we will send in space. There are 5 layers, because you have to imagine you have to go from higher than room temperature to 40K on one side to the other side. So you need very good thermal shielding there. And when we launch, they are actually, they will be stored in a structure. It's kind of what we call unitized pallet structure. And this is a rigid structure that will protect the Sunshield during launch. So the Sunshield is folded on both sides of the spacecraft. And here, basically, what you have is the spacecraft, the 2 structures, and a mock-up of the OTIS, because OTIS is in a cryogenic chamber. So they were testing that everything was fitting together. And you can see the hardware is there, and I think the next slides, they are basically showing the Sunshield is one of the complex elements, okay? Because you need to fold it, you need to pin it also, because during launch you don't want layers to rattle against each other, and then you will also need to test the unfolding. And it's always complicated, because you imagine all this hardware is actually designed for 0G. And usually in these pictures, in the previous picture it was probably more visible, you have all this yellow stuff. All these yellow stuff, they do not belong to the observatory. They are what we call ground support equipment, and a lot of them are there just to offload gravity, just to make sure that you don't damage things by trying to use them with 1G. And so when you practice deployment, as an example, you have a very complex setup. And here what you see is the folding process, where it's held also like that. And I think that's once folded. And on the side, you see the two white tubes. They are actually the real flight tubes that will extend, and in flight, they will basically deploy the Sunshield. So you see, the hardware is there. We are now more in integration, still some steps, because we have still 2 blocks, independent blocks, but also still some testing. And just to finish, basically, that's my, I have only one slide after that, is what's next, what next? Basically, OTIS, we are reaching the end. Okay, by the end of the year, normally OTIS will be shipped to California, to Northrop Grumman premises, where it will be integrated on the spacecraft and Sunshield. So we need the complete integration and testing of the spacecraft plus Sunshield. We need to put everything together. We have to test deployment. We have to go through a last series of environmental testing with everything together, so acoustic and vibration. But you see here, there's no cryogenic testing. Basically, the cryogenic testing of OTIS, it's the last time before really being in space where we could actually use the instruments and the telescope at operating temperature. Then, as usual, when you do acoustic and vibration test, after that, you just check that everything is right. There's always this really very systematic sequences. Then you pack everything and you ship JWST to French Guiana, and actually you ship it because it's going by boat and we'll go through the Panama Canal. And you get ready for launch in Kourou. There's always, you need to fuel and things like that, so it's not an immediate thing, you arrive, you launch, and then you launch. And then you're in space and commissioning science, so it's not more interesting, but additional things happen. But I'm not covering the after launch thing. So message is JWST is in good shape. There's no indication that it will not be really the powerful observatory we promised. We still have a lot of work in front of us, meaning we should not say we are done. We still have work. Launch in spring 2019, start of the observation in winter 2019. And as I said, meaning I think I'm preaching to you say preaching to the choir. In the sense, if you're here, it's because you're considering using JWST. But and I hope you will enjoy this workshop. So thanks.